Hi, my name is Robin, and you are welcome back to my channel. In this section, I'll be teaching you linear inequalities involving quotients. Let's dive right into it. So, I will quickly explain what is meant by quotient. 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 This is the result gotten when a number, or we can say a variable, or we can say expression, divides another number, or we can say a variable, or we can say expression. So all I'm trying to say here is that if I say 10 divided by 2, 10 is a number, 2 is a number. If I divide 10 divided by 2, I'm going to get 5. This 5 is known as quotient. Okay? If I pick a variable x and I divide it by another variable y, and let's say the result I'm getting is 3. This also is a quotient. Let's pick an expression, x plus 3, another expression, x minus 2. Remember, this is linear expressions, okay? So, if I say is equal to 0, the 0 I'm getting is the quotient. So, quotient is the result gotten when a number or a variable or an expression divides another number or variable or expression. So that is what is meant by quotient. Now that you know the meaning of quotient, now let's link it with linear inequalities. So linear inequalities involving quotient simply means that rather than me having equality sign, as you have seen here, I'll be having the inequality signs, which makes it linear inequalities involving quotient. For an example, I have x plus 3 divided by x minus 2 greater than 1. X divided by 2x plus 1 less than 0. So this expression, this inequality is involving quotients. Can you see that? So the next phase we are going to go to are the rules of solving linear inequalities involving quotients. Now let's take the rules for solving linear inequalities involving quotients. There are 2 basic rules that you need to know. Okay? So, rule 1. If P over Q is greater than 0, then P over Q must be positive. Remember, it's greater than 0. Okay? Then P divided by Q must be positive. So when P over Q is positive, or I can write it like this. I can write it like this. For P over Q to be positive, positive simply means this. For P over Q to be positive, then either P is positive P is positive and Q Q is positive, or P is negative and Q is negative. Let me explain this, okay? But before I explain that, you need to remember, you need to note this. This is very, very compulsory for you. Plus divided by plus is plus. Plus divided by minus is minus. Minus divided by plus is minus. Minus divided by minus is plus. Okay. So now I'm saying, rule 1 is saying for P over Q to be greater than 0. It simply means P have to be positive and Q has to be positive. Or P has to be negative and Q has to be negative. So that simply means here P over Q is equals to plus divided by plus. This will be plus. You can see that. Or P over Q is equal to minus divided by minus. That will be plus. So for P over Q to be greater than 0, it simply means P over Q has to be positive. And it can be positive when P is positive and Q is positive, or P is negative and Q is negative. Now, one thing you also need to know is that, remember, this is greater than, okay? But this rule also works for greater than or equals to. Also works for greater than or equals to. So all I'm trying to say here is that if you have something like this, the rule also works for greater than or equals to. So rule 1 is simply for greater than or greater or equals to. Do you understand that? That is rule 1. Now, let's go to rule 2. Now, for rule 2, if P divided by Q is less than 0, then P divided by Q P divided by Q is negative. Less than 0, that is negative. So for P divided by Q to be negative, for it to be negative, you already know negative is this. For it to be negative, then either P is positive and Q is negative, or P is negative and Q is positive. So all I'm trying to say here is that P over Q, if it is greater than, if it is less than 0, it simply means P over Q is going to be negative. Okay? And for it to be negative, that simply means P will be positive, Q will be negative, or P will be negative and Q will be positive. because if I have P divided by Q, that will be plus divided by minus. That is minus. P divided by Q, this will be minus divided by plus, and this will be minus. So for P divided by Q to be less than 0, P divided by Q has to be negative. And for it to be negative, these are the conditions for it to be negative. Also remember that this also works for rule 2, works for less or equals to. Okay? It also works for less or equals to. So now, we have 2 rules. But to any of these rules, there are 5 steps that we need to follow. To any of these rules, there are 5 steps that we need to follow. Now, let's look at an example where we are going to apply this rule and all the steps necessary. So now we have this question. Solve and write the solution in interval notation. So we have for question A and for question B. The difference between A and B is just the inequality sign. So, solution. Let's start with A. X minus 1, x plus 3 greater than 0. Here, because it's greater than 0, we already know that we are talking about the first rule. But let's start with the steps. So, step 1. Step 1, always make sure that what is on the right hand side is 0. Always make sure what is on the right hand side is 0. And here, the question itself is already telling us that what is on the right hand side is 0. This is the left hand side, and this is the right hand side. So on my right hand side, I have 0. That is the only thing I have there, which is correct. So for step 1, always make sure that what is on the right hand side is 0. So all I'm trying to say is that if you have a question like this, for an example, you can see on my right hand side, I have 3. Okay? But I always need to make the right hand side to be 0. So I can take this 3 to the other side. It will be x minus 1 over x plus 3, then minus 3 greater than 0. You can see that now. So for left hand side, I have this, and for right hand side, I have 0. So step 1 says always make what you have on the right hand side equals to 0. So from the question itself, we already have equals to 0. So no problem here. Now for step 2. Step 2 is talking about critical points. And for this critical point, we need something that will make the expression 0 or undefined. I'm going to explain this. Okay, let's assume I have 2 over 3. Okay? This is numerator, and this is denominator. Okay? So, what can make this expression equals to 0? That is, if the numerator is equals to 0, the expression will be 0. How? If I say 0 over 3, 0 over 3 is 0, you can see. So what can make the expression equals to 0 is when the numerator is equal to 0. So that is this part of it here. Okay? Now, for undefined, what can make 2 over 3 undefined? A fraction can be undefined when the denominator is equal to 0. So if I say denominator is equal to 0, I have 2 divided by 0. 2 divided by 0 is undefined. So that explains this part. So how do we relate this now to our inequality? I will explain that now. Okay? So here, step 2 is that we want to get the critical points, and critical points are gotten in terms of 0 and undefined. So for the 0 part, that simply means numerator will be equal to 0, right? That is what I just explained now. So what's my numerator here? X minus 1. So x minus 1 is equal to 0. That means x is equal to 1. That is one critical point. Now, for the undefined part, denominator must be equal to 0. And what's my denominator? X plus 3 is equal to 0. So, which simply means x is equal to minus 3. So, the critical point is at x is equal to 1 or x is equal to minus 3. So step 2 is to get critical points. Now let's go to step 3. Now step 4 is to get the interval of interest. I will explain. Remember, we already have our part A, part B, and part C. And to every part, it has its own interval. So now we want to know which interval is of interest to us in this question. Now, what we need to do is that for part A, we have minus infinity, comma minus 3. Let's pick a number between infinity and minus 3. From minus infinity to 3, we can pick, let's say, 5. Just pick a number, any number in between that. So if x is 5, let's put 5 minus, if x is minus 5, so x is minus 5, minus 1, minus 5 plus 3. I'm just representing x with the interval that we use. So minus 5 minus 1. Minus 5 minus 1 is minus 6. We are not particular about the value. We are only particular about the sign, if it is positive or negative. So minus 5 minus 1 is minus 6. That means numerator is negative. You see that? Then denominator, minus 5 plus 3. Minus 5 plus 3, that is minus 2. So denominator is negative. So here, minus divided by minus, we are going to get positive. So this part A is positive. Okay? Now let's go to part B. Part B, pick a number between minus 3 and 1. Okay, let's say I'm picking minus 1. Okay? So let's put my x is minus 1. So minus 1 divided by minus 1 plus 3. Minus 1 minus 1, that is minus 2. So that simply means negative, right? Numerator is negative. Divided by minus 1 plus 3, that is plus 2. So that simply means denominator is positive. So minus divided by plus. So this is negative. So part B is negative. Let's go to C. Pick a number between 1 and infinity. Let's say I'm picking 3. X is 3. So 3 minus 1 and 3 plus 3. So 3 minus 1, that is 2, which is positive. 3 plus 3, that is 6, which is also positive. So I have plus divided by plus. So this is positive. Now, remember the question says greater than 0, and that is rule 1. Rule 1 simply means when the quotient is greater than 0, it simply means it's positive. Rule 1 says P divided by Q greater than 0. It simply means the quotient has to be positive. So which parts give us positive here? Part A is positive, and part C is positive. So the interval of interest is going to be this. That is from part A union, because with this one, then part C is 1 comma comma plus infinity, or you can write infinity. So this is the interval of interest. So our interval of interest is basically what this is telling us, positive. So this is positive for part A and part C is positive. We cannot pick B because B is negative. So this is interval of interest. Now let's see what is going to happen in step 5. Now step 5 is to pick our solution. Remember that from our interval of interest, we have this and this. So we need to see if this satisfies our inequality. Remember, we have greater than 0. Okay, greater than 0. And if I look at my numerator, remember we got our critical pointers -3 or 1. Okay, so this is for the denominator and this is for the numerator. Now for the numerator, we are concerned about the numerator part. So when x is 1, if I say 1 minus 1, this expression becomes 0, right? And is 0 greater than 0 is false. Okay? 0 greater than 0 is false. So it simply means 1 cannot be part of the solution. Okay, 1 cannot be part of the solution. You don't have to check the denominator part because that is undefined. You will always disregard that. We're only interested in the numerator part. And the numerator part, we have 1. And if you put 1 minus 1, that will be 0. So 0 on the left-hand side greater than 0 on the right-hand side. That is false. So it simply means 1 cannot be part of the solution. So our solution is going to be this one, infinity minus 3. Remember, minus 3 cannot be part of the solution because that is undefined. Union 1 also cannot be part of the solution because 0 cannot be greater than 0. So this will be the solution. You can see nothing has changed from the interval of interest because of this. But let's say we're doing for B. For B, you know, the only difference is just greater or equals to 0. So you are still going to solve B the same way you have done. You are still going to solve B the same way you have done A through all the steps. But step 5 will be different for B. For step 5, remember, we want to pick solution now. So, and we said we are only particular about this. This is our critical point. And we're only particular about the numerator, right? Okay, now, numerator is 1, right? So 1 minus 1, that is 0. So everything on the left-hand side is going to be 0. But remember, there is equal to 0 here. So 0 is equal to 0, which is correct, true. So it simply means 1 is part of the solution for B. So I will rewrite my solution to be this. You already know why we are using this, right? Then union. Now, 1 is part of the solution. So that would be square bracket. You know this from the previous video. So 1, then infinity. This is normal bracket. You see that? You see the difference between question A and question B. It's just the way you represent it in terms of interval notation. The reason why I said 1 is part of the solution is that this is equal to 0. Okay? Now, let's take other questions. Okay, now let's see question 2. The A part. So x plus 2 over x minus 4 greater or equals to 0. Remember, step 1, left-hand side must be equal to 0. And in this question, our left-hand side is equal to 0. So we are done with question 1 and step 1. Step 2, we need to get the critical point. And critical point in terms of 0 and undefined. And when you're talking about 0, you talk about the numerator. So my numerator is x plus 2 is equals to 0. So x is equals to minus 2. And undefined, you talk about denominator. So denominator x minus 4 is equals to 0. That is x is equals to 4. So the critical point is at x is equals to minus 2 or 4. That is step 2. Now, step 3 will represent this on a number line. So I have minus 2 and I have 4. Okay? So x. So now, here, what is the interval here? Remember, this is continuous, right? This is continuous, this is continuous in this way, and this is continuous in this way, and this is interval between this. Right. So this is minus infinity minus 2, easy. And this is minus 2, 4, easy. And this is 4, 2 plus infinity, easy. So what is the next thing now? Step 4, you want to check your sign. Pick any number between minus infinity and minus 2. So let's say minus 4. Because minus 4 will fall in between there. So minus 4 plus 2, x is minus 4 plus 2, then minus 4 minus 4. So minus 4 plus 2, that is negative. Minus 4 minus 4, that is negative. So this is negative divided by negative, and this is positive. So A part is positive. So let's check the B part. What is between minus 2 and 4? What is between minus 2 and 4? We can say 3, right? 3. So let's put 3 as x as 3. 3 plus 2. So 3 plus 2 and 3 minus 1 and 3 minus 4. 3 minus 4. 3 plus 2, that is positive. 3 minus 4, that is negative. So plus divided by minus. So this is negative. You see that? Now let's go to C. Let's pick a number between 4 and infinity. Let's pick 5. S is 5. 5 plus 2. So 5 plus 2 and 5 minus 4. 5 minus 4. 5 plus 2 is positive. 5 minus 4 is positive. So positive divided by positive. So this is positive. Now, let's come to this question. Greater than or equals to. That is rule 1. Simply means the quotient must be positive. And what is giving us positive here? A and B. So that is minus infinity minus 2 union 4 comma infinity. Now, that is step 4. Now, step 5, let's pick our solution. Now, picking our solution, I've told you what is necessary for us. Remember, your critical points are minus 2 or 4. And what is important for us here is the numerator. And this is what the numerator gave us, right? Numerator. Okay, you can see it from here. Okay, so we are only concerned about the numerator. So let's put numerator minus 2. So minus 2 plus 2, that is 0, right? So everything on the left hand side is 0. And 0 is equal to 0. So which simply means that is true. So minus 2 is part of the solution. That is what it means. So minus 2 is part of the solution. So my solution will be, I have minus infinity, comma, minus 2. But minus 2 is part of the solution. So it will be a square bracket. You can see that because it's part of the solution. Then union, comma, is 4 part of the solution? No, because 4 is from the denominator. And I said we are only concerned about the numerator because denominator will give you undefined. So it is still normal bracket, then infinity. So this is the interval notation. Easy. So the only difference between step 4 and step 5 is that you have to use step 5 to consider which is actually true for the inequality. Now, for B, x minus 2 divided by x plus 4 greater or equals to 0. So here, solution. So critical point is at x is equal to 2 or minus 4. You already know how to get the critical point. So when x equals to 0, x minus 2 is equals to 0, s is 2. When x plus 4 is equals to 0, s plus 4 is equals to 0, so s is minus 4. So these are the critical point. The next thing is to put it on the number line. Okay, this is minus 4 and this is 2. So this is A, this is B, and this is C. So remember, this is continuous. This is also continuous. This is between this and this. Okay? So the interval here is minus infinity minus 4. The interval here is minus 4, 2. And the interval here is 2 to infinity. Now, for part A, let's pick a number between minus infinity minus 4. That is minus 6. So x is minus 6. So minus 6 minus 2, minus 6 plus 4. Minus 6 minus 2, that is negative. Minus 6 plus 4, that is negative. So it is negative divided by negative, that is positive here. Let's go to B. Let's pick a number between minus 4 and 2. We can pick minus 3 or we can pick minus 2. So let's pick minus 2. So x is minus 2. Minus 2 minus 2 over minus 2 plus 4. Minus 2 minus 2, that is negative. Minus 2 plus 4, that is positive. So minus divided by positive. So that is negative. Okay. The last part, pick a number between 2 and infinity. Let's pick 4. X is 4. So 4 minus 2 and 4 plus 4. 4 minus 2, that is 2. That is positive. 4 plus 4, 8. That is positive. So positive divided by positive. So this is positive. So I have two parts. I have A, B, C. And for this inequality, it says greater or equals to 0. And when it is greater or equals to 0, our quotient needs to be positive. So which part is giving us positive? Part A, part B, part A, and part C. So this is minus infinity, comma minus 4, union 2, comma infinity. So, and the last step is to pick our solution based on the inequality, right? And we are only concentrating on the numerator. So our numerator is x is equals to 2, right? So x is equals to 2. That is our numerator. That is what our numerator gave us. Okay? So let's put x equals to 2. So when x is 2, that is 2 minus 2. That is 0. So everything here is equals to 0 on the left-hand side. So 0 will be equal to 0, which is true. So it simply means 2 is part of the solution. So rewriting this, this will be this. Minus 4 will not be part because that is from undefined. And 2 is part of the solution. It will be square bracket. Then 2, then infinity, normal bracket. So you can see the solution. Now, let's take question 3. Let's take the A part of that. A 4x over x minus 6 less than 1. Remember, first step, right hand side needs to be equal to 0. In this case, our right hand side is 1. So I can take 1 to the other side. So that will be 4x over x minus 6 minus 1 less than 0. So this is correct now for first step. Now, the only thing here is that you need, before you go to step 2, you need to simplify. Okay? We want to simplify. How do we simplify this? This is very easy. Remember that this is over 1, right? That is 1 over 1. So the LCM of 1 and minus 6 is x minus 6. So what I'm trying to tell you here, which should make it very easy for you, is that you can rewrite this as 4x over x minus 6, okay? Minus, you write the 1, you can say x minus 6 over x minus 6. You can see that. So, because this is the only denominator we have here, so just put it on the side of, Because if I say x minus 6 cancel x minus 6, I will still get my 1 here. It's like I've done nothing. So that is what it means. So that is why I'm putting x minus 6 there on up and down. So that is 1. Put x minus 6 over x minus 6. So it's like I've done nothing here. So now, what do we do here? We can now say LCM is x minus 6 because x minus 6 is common. So this is 4x minus 1 bracket x minus 6, right? Less than 0, less than 0. So this is 4x, open the bracket, minus x plus 6 over x minus 6 less than 0. 4x minus x, that is 3x plus 6, then x minus 6 less than 0. So now, we have gotten this, so we can now go to step 2. Now, on step 2, remember, you are particular about your critical points, and that is based on using numerator equals to 0 and denominator equals to 0. So my numerator, our numerator here is 3x plus 6 equal to 0. So here, it should be 3x is equals to minus 6, x should be minus 6 over 3, which is minus 2. Okay, for denominator, that is x minus 6 equals to 0. That is x is equal to 6. So the critical point is at x is equals to minus 2 or 6. Now, what next do you want to do? You want to represent this on a number line. Now, putting this on a number line. So I have minus 2 and I have 6. So this is A, this is B, and this is C. Remember, this is continuous, and this is in between. Okay, so now for A, let's pick a let's put our interval minus infinity minus 2. For B, let's put our interval minus 2 and 6. For C, let's put our interval 6 and infinity. So the next thing is to pick a number between the interval of A. Let's pick a number between minus infinity and minus 2. Let's pick minus 4, right? 4, x is minus 4. 4 times minus 4 over minus 4 minus 6. 4 times minus 4, that is minus 16. See, it's negative. Minus 4 minus 6 is minus 10. That is negative. So this is minus divided by minus. And this is positive. Okay? Let's pick an interval. Let's go to B now. Pick an interval between minus 2 and 6. We can pick 4. 4 times 4, then 4 minus 6. 4 times 4 is 16. That is positive. 4 minus 6, that is minus 2. That is negative. So positive divided by negative, that is negative. That is for B. Let's go to C. Pick a number between 6 and infinity. We can say 8. So 4 bracket 8, then 8 minus 6. 4 bracket 8, that is 32. That is positive. 8 minus 6, that is also positive. So positive divided by positive, that is positive. Now, the next thing is to check our inequality, to pick our interval of interest. Our inequality says less than, what did we get? We got our inequality. We said we got 3x minus 6, 3x plus 6 over x minus 6 less than 0. This is what we simplified when we continue. So this is our inequality. So our inequality here says less than 0, right? Less than 0. And for it to be less than 0, it simply means you are only interested about the negative, the quotient that gives the negative. So the negative here for A, B, C, which one gives negative? This is positive. This is positive. So the only one that gives us negative is this one here. And that interval is minus 2, 6. So now the last part is to pick our solution to see if this is represented well. So remember, we're only interested in the numerator. The critical point from numerator is -2. So if I put -2 here, 3 minus 2, that is -6 plus 6, that will be 0. So everything on the left is 0. So 0 less than 0, which is false. So it simply means -2 is not going to be part of the solution. So we are going to have this kind of bracket, -2. And we already know 6 is not going to be part of the solution because that is from undefined. So this is our solution in the interval notation. Or you can write it in terms of the inequality notation, which is this. But if this question were to be greater or less or equals to, that means equals to 0, it simply means 2 will be part of the solution. In that case, this will be the solution. Sorry, this will be the solution. Or because -2 will be part of the solution, and it can be this less or equals to x and less than 6. -2 will be part of the solution, but in this case it is not equals to, so that is not what we have. So this is it. Now let's take b, 2x over x minus 4 less than 2. Remember, step 1, right hand side must be equal to 0. So let's take 2 to the other side. That is 2x, x minus 4 minus 2 less than 0. So this is 2x, x minus 4. This is like saying x minus 4 and x minus 4. Because if I cancel x minus 4, cancel x minus 4, I will still have this back. So it's like I've done nothing. So that is what that one means. So we have this. So LCM is x minus 4. Okay. So this is 2x minus 2x plus 8. So 2x minus 2x, that is 0. So you have 8 over x minus 4 less than 0. So in this case, you can see that we only have x in the denominator. So your critical point, critical point is at, for numerator, there is no critical point because 8 will always be 8. It's a constant. But for denominator, that means denominator, that is x minus 4 is equals to 0. So x is equals to 4. So critical point is at x is equals to 4. So in this case now, we have to create our number line. Now, creating our number line, okay, x is equals to 4. So let's say 4 here. Okay, so this will be part A and part B. Okay, this is continuous and this is continuous. Okay, so here, what do we have? Interval here minus infinity and 4. Here, 4 to infinity. Now, the next thing we want to try is, because this is less than 0, if it is less than 0, that means we are talking about negative. So let's put an interval between minus infinity and 4. Let's say 3, right? 3. So 8 divided by 3 minus 4. 8 is positive, 3 minus 4 is negative. So plus divided by negative. This will be negative. Okay. Then let's pick an interval here. Let's pick 6. 8 divided by 6 minus 4. This is positive, this is positive. So positive divided by positive. So this is positive. And as we said, this is less than 0. We are looking for the negative part of it. So the interval is minus infinity and 4. But now we need to check to pick our answer. But remember, when you are picking your answer based on your numerator. And in this case, our numerator doesn't have any x value because it's a constant value. So in this case, your interval of interest will be the same thing as your solution. So our solution here is minus infinity less than 4. Okay, or we can write it in an inequality interval, which is minus infinity minus infinity less than x and less than 4. Easy. Remember that if this were to have equal to 0, it will not still matter, because when it's equals to 0, we only need the numerator to make everything equals to 0, and our numerator does not have any x value. So your answer still remains the same, because the only x value we have here is at the denominator, and you do not use the denominator to pick your solution. But that is not what we have, so I'll remove that. Good. Now let's take this question. So it should be 3x x minus 4. Remember, the right hand side must be 0, so I can write this as this. Okay, so this is 3x x minus 4 minus 2 x minus 4 over x minus 4. Like I said, this can cancel out. It does not make any difference. So this is x minus 4, and this is 3x minus 2 bracket x minus 4 less than 0. So this is 3x minus 2x plus 8 over x minus 4 less than 0. 3x minus 2, and that is x plus 8 over x minus 4 less than 0. Now in this case, let's get our critical point. So that is based on our numerator and denominator. Numerator x plus 8 is equals to 0, so x is minus 8. Then our denominator, that will give us the undefined. X minus 4 is equals to 0, that is x equals to 4. So the critical point is at x is equals to minus 8 or 4. So in this case, let's put our number line. So minus 8 and 4, okay? Minus 8 and 4. So this is A, this is B, and this is C. So our interval here is minus infinity to minus 8. Interval here minus 8 to 4. Interval here 4 to infinity. So let's put our sign now. So if I choose a number between that, so minus 10, let's put minus, that is minus 10 plus 8 over minus 10 minus 4. Minus 10 plus 8 is negative, minus 10 minus 4 is also negative. So negative divided by negative, this is positive. The next one, let's pick an interval between minus 8 and 4. I can pick 5. No, sorry, I can pick 3. So put s as 3. 3 plus 8 and 3 minus 4. 3 plus 8 is 11, that is positive. 3 minus 4 is minus 1, that is negative. Positive divided by negative, this is negative. Okay, let's pick a number between 4 and infinity. Let's pick 5. So 5 plus 8 and 5 minus 4. 5 plus 8, that is 13, that is positive. 5 minus 4, that is 1, that is positive. So positive divided by positive, that is positive. So now the next thing is now to pick to get our interval of interest. So our interval of interest, you already know that this is less than 0. And when it's less than 0, we are only interested in negative. And what is giving us negative is this interval. So that is -8 and 4. So now let's pick our solution now. And remember, for you to pick your solution, you're only interested in the numerator. What gave us numerator? X is -8. So -8. So -8 plus 8, that is 0. So everything here is 0. Is 0 less than 0? That is false. So it simply means -8 cannot be part of the solution. So it's still going to be this bracket and 4. Remember, 4 cannot be part of the solution because that gives you undefined. But in a case where this is with equal sign now, okay, so -8 plus 8, that is 0. 0 is equal to 0. That means -8 will be part of the solution. In that case, you can write it like this. -8 will be part of the solution. And in terms of inequality interval, this will be -8 less than x less than 4. But for this one, in terms of the inequality interval, it will be -8 less or equals to x less than 4. You see the difference now? But that is not what we have. So I will take out this one. So here, this is our solution. Or we write it like this, the inequality interval. Easy. Let's take one more question. Now, let's take question 5. The first one, A, 5 divided by x squared minus 20 minus 2x minus 15 greater than 0. Here, first step is that right-hand side must be 0, and our right-hand side is 0, which is good. So 5 over, for the denominator, we can factorize, okay? X, 5, 3. This is minus plus. For those of you that don't know how to factorize, click on the top right hand corner of this video to learn how to factorize. Now let's continue. So now here is to get critical points. And remember, getting critical points, we use numerator and denominator. But our numerator here does not have x value, so it is not important for numerator now because there's no x value. We only have 5. 5 will always become 5. But for the denominator, so we have x minus 5 is equals to 0 and x plus 3 is equals to 0. So x minus 5 is equals to 0. That means x is equals to 5. X plus 3 is equals to 0. That means x is equals to minus 3. So the critical point is at x is equals to 5 or minus 3. So what we need to do now, we need to put this on a number line. So this is minus 3 and this is 5. Okay? So this is A, this is B, and this is C. Our interval, remember this is continuous, and this is in between. So minus infinity, and minus 3. This is minus 3 and 5, and this is 5 and infinity. So now we need to check based on our points now. Let's talk about for A. Let's pick a value between minus infinity and minus 3. Let's pick minus 5. Can you actually pick minus 5? Yes, let's pick minus 5. So 5 divided by x is minus 5, then minus 5 plus 3. So 5 is always 5, which is positive, divided by minus 5, that is minus 10, that is negative. Minus 5 plus 3, that is minus 2, negative. So for this one, I have plus divided by minus. So this is plus divided by plus. So this is positive. Easy for that one. Now, for this interval, minus 3 and 5, we can pick 4. So that would be 5 divided by 4 minus 5, 4 plus 3. 5 is always 5, that is positive. 4 minus 5, that is minus 1, that is negative. And 4 plus 3, that is 7, that is positive. So this is plus divided by minus and plus. So in this case, this is plus divided by minus. So what do we have? Negative. Okay? The last one, let's pick a number between 5 and infinity. Let's say 8. 5 over 8 minus 5 and 8 plus 3. So this is positive. 8 minus 5 is positive. 8 plus 3 is positive. So this is positive divided by positive. So this is positive. So this is positive divided by positive divided by positive. So this is positive divided by positive. So this is positive. So now, since we know that our inequality is greater than 0, that means our quotient needs to be positive. So what gives us positive here? A and C. And for A, we have minus infinity, comma minus 3. And for C, we have 5 and infinity. So, and the last step is to pick the solution. And for us to pick the solution, we need numerator, value of x. But in this case, our numerator does not have value of x. It's a constant. So we only have denominator, and we cannot use denominator to pick solution. So in that case, your interval of interest becomes your solution. So this is our solution. Now let's take B. 1 over 3 minus 2 over x squared less than 5 over 3x. Remember, step 1, your right hand side always needs to be 0. So in this case, I can say 1 over 3 minus 2 over x squared minus 5 over 3x is less than 0. Now, left hand side, right hand side is 0. Then what is the next thing is that, what is the LCM of 3x squared and 3x squared? In case you don't know how to get LCM, I will explain. Just write 3x squared and 3x. What can go here? So 3 here, 3 here, 1, and this is x. What can go? X, 1, x, and 1. What can go again? X. So what is that? 3 times x, that is 3x squared. So 3x squared is what I'm going to use to multiply. So the LCM here is 3x squared. How many 3 can you get in 3x squared? 3 cancel 3, you have x squared. X squared times 1, that is x squared. 3x squared divided by x squared. X squared cancel x squared, you have 3. 3 times 2, that is 6. 3x squared divided by 3x. 3 cancel 3, x cancel x. You still have 1x here times 5, 5x. So let's this. Okay, so in this case, I can rearrange this. If I rearrange this, this is what I have. Okay, and I can also factorize this one, numerator. I can factorize it. Factorize that. So this is x, and this is x, this is 6, this is 1, this is minus, and this is plus. That is how to factorize. Now, we want to get our critical points, and that is based on numerator and denominator. So our numerator, that would be x minus 6 is equal to 0, and x plus 1 is equal to 0. So x minus 6 is equal to 0, that means x is equal to 6. X plus 1 is equal to 0, that means x is equal to minus 1. So x is equal to minus 1, x is equal to minus, that is for numerator. Now let's do for denominator. Denominator is 3x squared, must be equal to 0. So in this case, x is equal to 0, because if you divide 3, if you divide through by 3, it's still x squared equals to 0, and square root both sides, x equals to 0. So here, the critical point is at x is equals to, we have 6 minus 1 or 0. Okay, the next thing is to put this on a number line. Now, let's put our number line. So we have minus 1, we have 0, and we have 6. So we have A, B, C, and D. So remember, this is continuous. This is continuous. So this will have an interval, and this will also have an interval. So this will be minus infinity to minus 1, between minus infinity and 1. So minus 1 and 0, 0 and 6, and 6 and infinity. So now, let's start with A. Let's pick a number between minus infinity and minus 1. Let's say minus 2. Okay? So let's put minus 2 here. So this is minus 2 minus 6. That will be negative. Minus 2 plus 1. That will be negative. Okay? Minus 2 squared. That will be positive. So we have negative, 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 and positive. So positive over positive, so here is positive. Okay, let's pick a number between minus 1 and a 0. So let's pick 0.2 or 0.5, minus 0.5, minus 0.5. So if I pick minus 0.5, that is minus 0.5 minus 6, that is minus 6.5, that is negative. Minus 0.5 plus 1, this will be positive. Minus 0.5 squared, definitely this will be positive also. So negative, positive, positive. Negative divided by positive, so this will be negative. Okay, let's pick a number between 0 and 6. Let's pick 4. So 4 minus 6, that is negative. 4 plus 1, that is positive. 4 squared, so this is positive. So negative, positive, and positive. So this is negative and positive, and this will be negative. Let's pick a number between 6 and infinity. That's, let's pick 7. 7 minus 6, that is positive. 7 plus 1, positive. 7 squared, and that is positive. So this is positive, positive, positive. So positive, positive, this will be positive. Now, according to our inequality, this is less than 0. And less than 0 simply means we're interested in the negative part of it. So which one is giving us negative? B and C. So, and that is telling us that it is minus 1, 0, okay? And is between, you can see, is an interval. So minus 1, 0, and 0, 6. So in this case now, in this case, we need to check something here. We need to see by picking our answer, and we use numerator to do that. So now our numerator is 6 and minus 1. If I put 6 here, everything will become 0 here. So 0 is less than 0, which is false. Because it is false, that means we are not going to have the value of x to be inclusive. So it simply means we're still going to maintain our brackets. So this is minus 1, 0, union 0, and 6. Okay? In a case where maybe you have this here, which is equal to 0, and if 6 equals to 0, and everything else equals to 0, 0 will be equal to 0, right? So it simply means the value of x for the numerator needs to be inclusive. In that case, that means 6 and minus 1 needs to be inclusive. That would be, for you to write this, it will be this one, this bracket. Can you see? Minus 1, 0. Union. We said 6 and minus 1. So for 6, it will be this. You see that? But in this case, we don't have equals here. So I will remove this one. So our answer is this. Now, let's take the last question, C. Now, C, x minus 5, x plus 3 less than minus 1. I will just do this one very fast, so because you already know what we are going to do. So now, since our inequality is less than 0, and when it's less than 0, you are particular about the negative part of it. So which is only this. So that will be minus 3 less minus 3 comma 1. But remember here, let's check the numerator. So when the numerator is equal to 1, if I put 1 here, everything on the left hand side becomes 0. 0 is less than 0, that is false. So it simply means 1 will not be inclusive. So this is our answer. Or you can write it like this. But in a case where this is with equal to 0, that means 1 will be inclusive. So that will be written like this. You can see this bracket. Or it can be this, because now 1 is inclusive. You see that? But that is not the case that we have. So I will take it out. So that is our answer. Easy. Wow, congratulations to you. You are able to stay to the end of this video. In my next video, I will be explaining how to solve quadratic inequalities. Hope to see you in my next video. Bye for now.